Nice. Okay, yeah, cool. Thanks, guys, for joining. Yeah, this is the second one of these, my architecture ones, and I really like these ones because they're quite practical. And, moving to the cloud is sometimes, limited by practicalness, right? There's lots of articles and things out there around, best practice designs and pie in the sky kind of things, and those things are great. But, many of us, such as we in Digitata, sit with a legacy system. And this talk is going to be about how we have transitioned that system into the cloud, and specifically AWS, in a bunch of phases over the last, I would say, year and a half. So that's what I'm showing you guys today. What Digitata does is we are in the telecommunications industry, and we dynamically price data, voice, and SMS. So we're the guys in charge of the price of data, SMS, and voice. We can change the price dynamically, and we change the price according to the time of day, where you are, your location. So think of it like spot instances, like what AWS does with spot instances. If there is no demand or little demand, then they make the compute cheaper, and basically that's one of the main use cases that we do. So at 3 a.m. in the morning, when there's no one connected on the tower, we can make the data and the voice a lot cheaper, and inversely at 5 p.m. in Santon, we can do the opposite to protect the network. So that's what we do. Right. So as I mentioned, we've been around for quite a number of years, around 13 years now, and our tech stack is basically a combination of these things. So it's Java. The majority of it is Java. We've always kind of followed a microservices architecture, to a greater and lesser extent, but we separate things, right? So if this thing is really good and at this, and that's the one thing it's good at. This thing is really good at this, and that's the one thing that's good at. So we've always kind of followed that philosophy. We also have some components written in Node.js, and then in terms of databases, we use Postgres, Redis, Mongo, and then we use ClickHouse as well, which is, I think if you guys are looking for an on-premise good on-prem columnar database, have a look at ClickHouse. It's really come a long way, and it's becoming something that we really kind of trust in. So, not a very fancy stack, the kind of classical enterprisey kind of stack, I guess, right? Java specifically is widely used in the telecoms industry and many other industries, but specifically in the telecoms industry, that's quite standard. Combination of Postgres, Redis, Mongo. And then because of our industry, this has traditionally been an on-premise game for us. Because of, telecoms and sensitivity sometimes around data, sometimes regulatory and legit, sometimes imaginary and, not legit, but whatever. It's traditionally been an on-prem game. However, last year that started to change. And in the last kind of 10 months, we've done 2 cloud deployments, which, as I said, is our first cloud deployment. So we've done the first 2 in the last 10 months, and I can see this and hope that this kind of accelerates. So this is the story around how we took a 12, 13-year-old tech stack, and I'm slowly, getting it into the cloud. Right. So how do we start? So, as you do, right, we started with a lift and shift. Okay. And, it's an easy way to start. It allows you to vertically scale. And by vertically scale, I mean, just make the computer bigger, right? So at least you have that, right? It's not so easy to scale horizontally, because that usually requires work on your architecture and stuff like that. But at least with a lift and shift, this is already a benefit that you wouldn't have had if you deployed it into an on-prem data center, as we usually do. So that's already a bonus. Then in terms of monitoring, I mean, because EC2 really integrates well with CloudWatch, that also, you win there. Maybe you already have a monitoring solution. Just make sure you have some kind of monitoring and detailed monitoring on your infrastructure. I also found it's an easy introduction to AWS for the rest of the team, because the only difference is the servers are now in the cloud, right? It's now in AWS. And in our case, the only kind of additional kind of upskilling that we had to do was on CloudWatch, basically, right? Because they already understand servers, they already understand our system. It's the same components. They run in the same way. They just run on an EC2 now. So it's a very practical way. And I think this is not news to anyone, but this is really, it's a practical way to start, and we've proven it in Digitata. Then, challenges, you are paying more. It's just a fact, right? You are paying more than you could be paying. And, as I mentioned, it's really not easy to scale horizontally, and you will probably overspec initially. You will make the EC2s bigger than they have to be, which is a lesson we definitely learned. Right, so this is our architecture for phase one, right? So it was a lift and shift, 2 massive EC2s. We put our computers in AWS and we said, we're doing cloud, right? Phase one. So very successful, but we knew there was more to be done, right? Then during phase two, we started looking at, what is the next step? The next step in our case kind of was obvious, because we already had some of our applications that were running in Docker, right? They were just running on the EC2s in Docker. So we took these components and we just changed them slightly, came up with some CDK templates to deploy them into ECS and using Fargate. And we put a load balancer in front of it. So this immediately allowed us to reduce cost, because we could reduce the size of the EC2s. We also immediately gained autoscaling, because we can put these things behind a load balancer, an application load balancer, and then use CloudWatch metrics to scale them out. So now we are starting to get into the world of horizontal scaling as well. And then, because we could reduce the size of the EC2s, this reduced our costs. So in phase two, we already started seeing cost reductions. So it was a combination of kind of right sizing or first moving, these components off, moving them into ECS, and then right sizing the EC2s. So that led to a cost saving there. Some of the challenges that we found was things that rely on disk mainly. So these applications, let me just add this. Our plan here was to do this with Fargate, so ECS Fargate. So from the beginning, we wanted to make sure that our containers can run in Fargate. So instead of, trying to first install the ECS agent on one of the existing EC2s, or maybe spin up a new EC2, we decided to take the leap and get the containers ready to run in Fargate. So ECS Fargate is where you don't have to manage any infrastructure. And the reason, we went for this kind of step is because we're already managing infrastructure in terms of these EC2s, which are hosting, very important components. So we decided for phase two, let's take the hit now and let's, jump a little bit ahead in our evolution. So we said, okay, Fargate. So the challenge with doing that in Fargate is if you have containers that are reliant on config on disk, as you do when you run them on EC2s, that's a challenge. And then other things such as bidirectional file comms. So this is a little service and maybe it loads a file every now and again that's written from another service. Those are the kinds of challenges that we face. Luckily, EFS allowed us to solve these challenges. So this is kind of what the phase two architecture started to look like. So this is the mobile network operator on the left here. They send us a bunch of data. There's also customers interacting with our system. This goes over VPN, goes into our kind of AWS account. And then the data is split two ways. So all the customer-facing data goes to the application load balancer, and then these are our containers. That's just the names of some of our internal microservices. Don't worry about it. What they do is they serve customer traffic. And then the other kind of feed is still straight to the EC2. So this is like files of data and data feeds, so like how busy are the cells, which is one of our important feeds, call records, SMS records, data records. So that still goes to the EC2s. The customer traffic is now served through the application load balancer using ECS Fargate, and these things can now scale. And in the middle, we have EFS. So we just created an EFS kind of volume, and we simply mount the same EFS. So these microservices that relied on files for config and stuff like that, they just read it from EFS. And the EFS is shared between all of the EC2s and the ECS cluster now. So this was the phase 2 approach. So any questions so far? All makes sense? We're all good. Cool.
Yes, all good. Let me just mute that.
Right. Okay.
Nico, sorry, I've got a question. In your initial phase 1, did you recreate the EC2 instances from scratch, or did you do a migration exercise with tools, or how did you create those initial EC2 instances?
So we used Ansible to create them because sorry, there's a bit of feedback there. And the reason we could do that is because we invested a bunch of time around a year and a half ago into deploying our system with Ansible. So even in the case of on-prem deployments, we deploy the system through Ansible. So that work really paid off here because we literally could just use those same Ansible playbooks and and deploy these EC2s. And in fact, we now make images every week of the system, so that we've got new images that we are starting to use for development and test environments.
Okay, cool.
So I hope that answers your question. So I think that saved us some time there. But there are tools and strategies to migrate stuff. I know, for example, if you're already using a VM hypervisor, there are I can't remember exactly which ones are supported, but you can export from certain VM kind of hypervisors and then import as AMIs, as Amazon Machine Images. So that is an option depending on what kind of virtualization technology you use.
Yeah, I know AWS has that Cloud Endure migration tool as well. I wondered if you may use that as well, but yeah.
Yeah.
Okay.
No, so I think we were. Yeah, excellent. Yeah, so we were lucky in that sense. We already had the playbooks available to just create from scratch. Cool. All right, so cool. So this was phase 2. Started to seeing some cost reduction. We added some horizontal scaling. So, we were pretty happy. But then we were like, okay, so what's next? Right. So for phase 3, we decided, we still have that old Postgres over there. We still have that old Redis over there. And we are still managing these things ourselves. So, I think it was one of the earliest services that Amazon launched was RDS. So let's use RDS and Elastic Cache in the place of Redis. We also looked at Document DB to replace Mongo, but I think you guys can already see there were problems with that if you look at the bottom right. But RDS and Elastic Cache and Document DB was kind of our approach in phase 3, and then of course move more of our applications into ECS. So after we did this, we actually managed to get rid of an EC2. So now we're only running one. We also are scaling more things horizontally. Another cool thing that came out of this was we started taking advantage of ECS's scheduled tasks functionality. So on these EC2, some of our services have to do with data ingestion and data loading and data transformation and stuff like that. These things don't have to run all the time. And in fact, even on the EC2s or even on the on-prem deployments, they're kind of on a cron, if you know what I mean. They're running every hour, every 15 minutes, every 2 hours, etc. So we decided to start taking some of those components, also put them in containers, and then run them as scheduled tasks on a schedule inside ECS. And that helped a lot into further reducing our EC2 footprint, because now we don't have to scale the EC2 for, you know, the perfect storm. If you guys know what I mean, we don't have to scale for when everything is running at the same time and we're getting lots of traffic from the customers, etc. So that was a really cool benefit. It was to leverage scheduled tasks for the things where it made sense. And then, of course, a big goal of this phase was let Amazon worry about the DBs, right? I don't want to worry about it. Let them worry about it. Then, again, challenges here was still around shared config. There were some iffy applications that were really sketchy there, but eventually we could make them all work. And then another interesting one was some of these tasks, some of these components were not what I call scaling aware. And we actually had to change here and there. It was small changes, but we still had to make slight changes. So, for example, take one of these data loader components. So, you know, if some of these components, if they were to start, they will just do work. But if you start another one at the same time, they'll end up doing the exact same work. You know what I mean? So we just had to build in a little mechanism, either of locking, so that if two of them do start at the same time, this one knows that another one is running so that it can exit. Or if you want to be a little bit more fancy, try and come up with some kind of work sharing kind of mechanism. But for this phase, we just decided we'll just lock. And if another instance of this task is running, we just exit. And then, as I kind of mentioned in the beginning, the challenge here was document DB. It was just too expensive, super stable, but in our use case, unfortunately, I have to say it was not cost feasible for us at all. So we actually went back to running Mongo just on an EC2 by ourselves. Yeah. So this is kind of what the architecture is starting to look like now. So still have the same kind of VPN arrangement. We still have our AWS cloud. You still have the traffic spinning in two over here. The difference is we just have many more services running, and we've added scheduled tasks. You know, so sometimes one of these are running, other times 5 of these are running, sometimes none of them are running. And we only pay, because we're using Fargate, we only pay for what we use. So this really results in a big cost saving in the long run. You still have EFS serving as our kind of, you know, interim file system that is shared. And now we've added RDS and Elastic Cache. Just a note of interest, we found RDS to be probably one of the most stable services that I've ever used in my life. It's not given us one issue. We are actually running on a much, much smaller Postgres than we used to deploy on EC2. It's just been my experience. It seems to perform at least as good, if not better, than trying to do it yourself. And then we also started using S3 for backups, file backups. So some of the files that the operator sends us, sometimes we have to reprocess that. So instead of, you know, creating big EBS volumes, we're making smaller EBS volumes, and we offload to S3. And then, as I mentioned, we replace Redis with Elastic Cache.
Nico,
So yeah.
I just wanted to ask, is this all running in one availability zone, or?
It's just in one availability zone. It's just in one availability zone.
Okay.
And the
I must
reason
say,
is,
you are hectic on saving if you go down from two machines down to all of this. That's awesome to actually see someone take the time to try and save the money.
yeah, Yeah, and so for us it was cost saving, but also just being a little more kind of elastic, kind of scalable. Trying to use the services, in a better, more optimal way, right? That was kind of our internal drive, and to the multiple availability zone question is. We actually had it running in 2 availability zones, the ECS cluster. The problem is, I won't bore you guys with my frustrations with the telecoms industry, but our customers have a limitation where they can only send to one IP, the specific customer that I'm talking about here. They can only set up their stuff to talk to this one IP, which is connected to the ALB, which meant we could, we didn't have to deploy anything into the other AZ. It's all running in one. Because even if we had put it into 2 AZs, the interface that they're talking to the LB is only in one because they're only using the one endpoint. So we wouldn't have gained anything. But that's on our radar for the future. Any other questions?
Nico, maybe if I may,
yeah.
Evening everyone. Not sure when to ask this question, but I'm interested in when, before each phase, when you did the costing of that phase, the commercials, working out what would it cost you, were you fairly accurate? I mean, of course, you made that assumption on the database that you, changed back to Mongo, but through these phases, were you fairly accurate using the online tools, or how did you price?
It's a very, very, very good question. It's a very good question. So what I can tell you is, if we go back, so we were very accurate on this, of course, because we knew exactly what we were going to deploy, right?
Yeah.
But what we found was we way overspec'd. So that was the one thing. On this phase, we actually, when we started, we didn't do a cost optimization exercise because we were just moving these 2 services, and they were already Docker containers. They were already containerized. So we decided, you know what, let's just try it and kind of see what happens. And then that kind of opened our eyes to, it's not just about being cool. We could see cost savings are coming here because we took away some load off of these EC2s because these things are running here now. So we kind of got a taste for that. And then when we went into phase 3, we actually did do a cost optimization exercise, and I think we came within around 20-30% of what it actually cost. So I didn't do the cost optimization exercise. My senior kind of architectural lead actually did that, and he did a fantastic job on that cost optimization. I'm not actually sure how he did it. But he was close. He was close.
No, cool. Thanks. It's good to know that you saved money all along the way as you optimized. It's a better system for cheaper, and that's really the point. Because we tell customers, when you lift and shift, you're going to pay more. Look, you get some benefits to it, but typically lift and shift. But as you say, you probably overspec the service. So do a first round. But this is great to see in action. I mean, literally breaking this thing apart and re-architecting it. It's awesome to see that, and the success you got with the cost over time. It's fantastic.
Yeah, I think it was a great learning journey for us so far. And I've actually got some numbers for you guys. So our phase 1 costs were around $3,000 US. That's really easy. You just add the cost of those 2 massive EC2s, right? Then phase 2. After phase 2, so after we downsized and everything like that, it was around $1,800, right? So the EC2, we downsized them, as I mentioned. So we found out we completely overspec. So okay, fine, And also remember, we started moving things into ECS, so we could downscale these. So we ended up in $1,800, and this was, I can't remember which month we pulled. I can't remember how long it was running, but this was basically, I remember it being around 2,000. So 1,800 fits right in there. Then on phase 3, And this is the same system. So we're below $1,000 now, and we're only using one EC2. And I'm only showing you guys the top 4 costs. There are some other costs here as well, which start adding up, but the total cost is $914. So we're running we've went from 3,000 to 1,000, let's call it 2,000 to around 1,000. And I found this extremely interesting. So this is also something that our lead architect prepared for me. So if you look between phase 2 and phase 3, obviously the cost, as we discussed, but look at the average amount of CPUs that we're using. So it was 34, it's now 11. And what he means by average is those are just the kind of permanent kind of tasks, Sometimes there are more, sometimes there are less, because we've got to schedule tasks and we have the ability to kind of horizontally scale. But we worked out the average, right? And then the same with memory, right? So we're basically using, on a permanent basis, half of the memory that we used to use. And same with storage. And then I didn't want to give away too much detail, but I thought that was interesting. He looked at it from the point of view of how much more efficient is the phase 3 design per bundle that we sell. So it's twice as efficient. And then how much more efficient is the phase 2 per subscriber that we serve? And it was 4 times. Yeah. So any questions?
Yes, Nico, from my side,
yeah.
How many people worked on this?
It was around 3, between 3 and 4, depending on how much manpower we were throwing at it.
Okay, no, this is really awesome. I mean, that's the whole thing of cloud, right? You must do the work to save money, otherwise you'll just pay. So
exactly. Yeah, exactly. And I mean, we had to put in time here, and they didn't work on it full time, but the work paid off, right?
No, well done.
Okay, and then if there's any other questions, we could just move on to the final slide. Yeah, sorry.
I just have one quick one. In what region did you deploy that? So your client was on-prem. What was the closest region, and was there any increase in latency, or wasn't that a problem at all?
So the first customer we deployed into Ireland because they were closer to Ireland on the internet. The second one we actually deployed into South Africa because they're one of our kind of sub-Saharan customers. In terms of latency, there's not that much difference. I think the latency from our Ireland, the customer that uses Ireland, the link between them and Ireland is around 100 milliseconds. And that's not something you're going to notice when you buy a bundle over a USSD. You're not really going to notice that. And then, the latency between our sub-Saharan Africa and Cape Town is around 30 milliseconds, 40 milliseconds. So, I mean, that's like, yeah. I don't think you're really going to notice that.
Mm-hmm. Okay, nice. Thanks.
But yes, it is something to be aware of, is, choose the right region for the customer. And actually, we are starting to get some problems with the second customer we did, where their network bandwidth has sometimes become an issue for our system. Yeah. So it is something to be keenly aware of, is the quality of the link and which region to use.
Okay. Nico, I have one question. So now that I understand you have multiple customers, now I know why you optimize, because you have multiple of these things per customer.
Exactly.
Exactly.
Okay. So this is a template that we are going to start using more and more and more and more. We've got many customers, so we've moved 2 of them into the cloud already. There are 10, 12 more, that I'm sure will start happening over the next 5 years.
Nico, and are you running these customers in separate accounts, or one account, one VPC, many VPCs? What's the networking config and the account config?
It's a VPC and an account per customer.
Okay.
Okay. We started off as you always do, with doing everything in one in one account, but we actually put that right around a year or so ago, and all of our the two customers are now in separate accounts.
Okay, that's cool. That's cool.
So from a billing point of view, I found that was a key driver to split them from billing point of view. Sorry?
I think you mentioned in a previous meetup you're not on Control Tower yet.
No, we're not.
Okay. Yeah. There's some cool stuff from it. Like if you say you've got, like you work in a regulatory space, there's a bunch of cool security controls that comes out of the box that you don't have to build.
Awesome. Yeah, cool. Something we need to look at. Nice, thanks. Thanks for that tip.
Nico, just a question from my side again. It's Sean.
Yeah.
Would you? I'm just asking because I'm actually working with one of the mobile operators in South Africa now with their AWS Direct Connect. Isn't it not possible to almost force your customers to say use Direct Connect because you know about the quality of that link? You don't have those connection problems.
Yeah, and I think if I could use a time machine and go back to Nico of earlier this year, I would strongly recommend that he tries to push that a little bit more. Yeah,
solve some problems, and it's not that expensive. Honestly speaking, because with these guys, we did some calculations of various types because you get different types, and how it all connects up, and they just went for the big one from the start because it was really cost effective.
Yeah, I think we made a mistake there. Honestly, it worked beautifully well for like the first 2 months, and then I don't know what happened. Something changed, or they have some challenges with something, and every now and again we see terrible network performance, and that is now starting to affect the system. So I think we made a mistake there. If I had to do it all over again, I think I would push more for Direct Connect, totally, 100%. Okay, cool. Just my last slide. So just some lessons we learned. Lift and shift is a good place to start. It is practical. It gets you accustomed to it. It gets you familiar. It's not a big leap for the rest of your team. It is a good place to start. However, I would urge you not to stop there. One of the first things you should do is hook your lift and shift architecture into CloudWatch if you can. If you have another solution that's already working for you, great. But if you feel you can improve your existing solution, or maybe you don't yet have one, start by hooking into CloudWatch. It's easy, it's simple. People see the benefit of having detailed metrics immediately. And that makes them start believing in cloud. I felt the easiest next step is ECS. Use EFS if you have strange services that need things on disk and need things to be shared. It is easy, simple, it solves the problem. As soon as you can, use RDS and Elastic Cache in our case. And then do not forget about ECS scheduled tasks. It is actually such an obvious thing, but it tends to be overlooked. You've got these tasks, they do some work, they don't run the whole time, so don't run them the whole time. Fargate and ECS scheduled tasks really go together well. If you do this, you will save costs and you will have a more stable, scalable system. And then, as we kind of touched just now from the question, if you work over VPN, please make sure your customer has the bandwidth. And then I just want to close off with, you probably don't need EKS. You probably don't need Kubernetes. Yes, it is a great tool. It is a great piece of technology, but you can get started with ECS, and you can kind of level up your architecture with ECS, I believe. Cool, that's it from me. Is there questions? Let me look at your faces.
If there are questions, let's keep them to 2 minutes because we're already running over.
Sorry.
No, that's fine. It's some very good questions and ideas and
Yeah.
points. So.
Very good questions.
Anyone?
Okay, cool, thanks.
Thanks, Nico.
Cool, thank you.
Yeah, thank you, Nico.
Thanks.
Lucien?
Thank you, Nico.
Lucien, you can start sharing your screen so long, and if anyone has a question, the last one, now's the time. Never mind, Lucien's on the ball. Okay. Lucien, I'm then gonna hand it over to you to introduce yourselves and tell us a bit about what you're gonna be presenting to us tonight. Don't forget to zoom when you talk about certain parts so that we can just get a better picture of it. Thanks, you can take it away.
Great. Just for a thumbs up if people can see my screen and hear me okay. Stuff. Great. So the application I'm showing is a client of mine where I'm consulting, and the use case behind this application is a web application, but under the hood we're running a complete serverless event-driven asynchronous application. And the purpose of the application was to create a portal for internal users. And these internal users would have a single pane of glass to be able to get access to different application teams and their data. And effectively, it was a brand new application team. So we've implemented a full-on agile approach. And we've split this up into 2 application teams. So I'm floating above the 2 pizza teams, and we have a team that looks after the front end and then a team that looks after the back end. Cool. So before I started, and when I met with the application team, I kind of had to understand the requirements that we were catering for, but also the landscape where we were building. And a place or a service that not many people know about is a service that's called AMS. I'll paste the link in the chat now. Just one sec. So AMS is AWS managing your control tower landing zone. And we're effectively controlled by these constraints. So we have a platform team, we have AMS, we're using professional services as well, and this is where we had built our application. Part of that will kind of dictate how we would build and use things. So they've implemented a lot of guardrails for us, and this is where things got quite complicated. So, for example, there's no ClickOps allowed. Everything has to be deployed by infrastructure as code, and that's where we use Terraform. And see Paul smiling there. That's great. So we use the approach of always using the CLI and then writing our infrastructure as code first, and specifically speaking to the developer box. So our backend code is a .NET, and this is specific to the organization's code set. And we use JavaScript for the compiled front-end code that I'll dive into a bit later. And yeah, we're using Visual Studio Code. So this is what our devs are using, and this is kind of split between the 2 pizza teams. And like I said, we had no previous legacy systems. We just had to integrate with them and kind of create a front end. So the control tower is centrally managed by the link I shared earlier. And in the control tower, we have some security services which we're leveraging. So we have Shield Advanced as well as Guard Duty. I seem to have missed that icon. But when we're taking a look at the web layer and from a security perspective, we're catering from a layer 1 to a layer 7 protection. And this is the only thing that we've exposed publicly. So it's compiled code in a bucket. We're using Cloudfront. We expose the bucket as the origin, and we have a firewall that's protecting Cloudfront as well as our API gateway. Specific to this, we created a subdomain in our AWS accounts and split this across the 3 environments, so dev, non-prod, and production. And these DNS records are all resolving via the on-premise data center. Cool. So diving into the networking layer. So we have had to take a consideration, which was using ping identity, and this was a trade-off that we needed to go through to match the organizational structure. So ping identity is used internally, and we weren't able to incorporate Cognito and then have that speak to ping. It was counterintuitive having 2 IDPs. So when our users logging in to the front end, we have a back-end Lambda authorizer checking the header token, and once the user is authenticated, we're passing that data back to them. So this is an ongoing connection. From a networking perspective, we're using Transit Gateway, which is using the direct connect on premise, and specifically we're speaking to a back-end API which is sitting in front of mainframes. So these mainframes have certain limitations where they need to turn off for maintenance, for scheduling, and this is what we're effectively polling and checking for. So when our users are logging in, they need to know if certain environments are online, they need to get certain data, and how do we manage this when these back-end systems are going offline, was why we went for the asynchronous application. So I'll dive into how we're using those services. But so our users are now, they've logged in, they're authenticating, and it's now past a certain time frame. So what we've done is we've used the service of Amazon EventBridge, and what we're doing is we've made a target to these step functions, and whilst we running these state machines, we're monitoring and tracking which services are failing and which ones are working, and this way we're always able to keep the whole architecture highly available. So as you can, when we speak to AWS Lambda specifically, also I do love the service, and it just has certain limitations, specifically to how long the execution runtime can run on Lambda. So with using step functions, we able to create dead-letter queues and cater for ensuring that the clicks that the user is doing, we're able to notify them when their data is ready, and these kind of sorts of things is where we've applied the asynchronous approach. From the VPC itself, we have an endpoint speaking directly to DynamoDB, and we're mostly monitoring the states of what the calls are making, and based on this, returning and scaling the data back to the user. Great. So from a pipeline perspective, we've used the entire AWS code suite, and what additional builds that we've done is once a developer now has pushed their code, it runs through the whole pipeline, and we've catered for a different build a different build environment to core Amazon CloudFront. So what this does is we built the business logic on top of DevOps, and when we're able to create these changes, they are implemented immediately through the CICD process, and the cache is then cleared, which will then be displayed back to the user. From a one architecture perspective, so this is catering for how we're using services that kind of sit underneath the hood. So we're using parameter store to store certain parameters for our API gateway. This is for when we need to change certain endpoints. We are able to pull that quite quickly. And this really helps between those two pizza teams that are working on the front end and the back end. From an encryption in transit and at rest, we're using Cert Manager to secure the certificates, and then KMS to encrypt the data at rest. From a microservice tracing perspective, we're using X-Ray. It's been brilliant out the box. We're able to see how long our code is running for, where these errors are at, and it's been quite fundamental for our building process. The application team is relatively new, and this was built out over a 3-month period over multiple sprints. And we started off first with just building the web tier and ensuring that we had DNS in our account. Trying to speak back to an on-premise DNS server in AWS is a huge pain, and I definitely advocate for creating a subdomain and pointing that back to on-prem from a hybrid perspective. So the front end was the first phase. We needed to build this on top of catering for our single sign-on. So this was writing the application code to speak to ping. And this was the trade-off where we weren't able to use Cognito and gain the benefits of running the user authentication across the edge where we wanted to. And what we had to do was take a few steps back, write a few Lambda functions, and then just pull the token from ping, authenticate our user, and then hand that back. The good thing about AMS was the on-premise DC to the VPC has been set up, but we have no control over that. We need to raise specific requests, and we need to ensure that we have the correct security groups opened. But effectively, our Lambda functions are calling a backend API layer, and we're able to show a dashboard of which of these separate systems does the internal user need to access. And what we've done is we've consolidated a lot of the need for using a whole bunch of internal tools through the single kind of single pane glass approach. The last planning increment was specifically around using the event bridge as well as state machines and SQS, and this was specifically using scheduled rules, and we used cron formatting times, which we were able to identify through an MVP approach. So we had no idea how this API layer would work, but we needed to ensure that we could see when it went down. And secondly, we were able to keep that message in our application and ensure that it doesn't get lost. So that's it. I'm open to questions.
What did you guys use step functions for? What did you think of step functions?
What did I think of step functions? I found the standard execution time to be quite ordeal. the benefit was we had longer runtimes. So specifically, where Lambda fell short was how long these executions could run for. And in state machines, we were able to kind of execute what we needed to orchestrate those responses, and not diving too deep into the detail, but effectively we needed to check what data needed to be sent back to our user, and being able to track the execution of that task. That way, we were able to cater for that resiliency specifically, and that's how we solved that problem specifically. Was when we are making these calls, how we ensuring that we're validating, we're able to chain these executions, and it was it was a beautiful way to kind of decouple that specifically.
Yes, awesome. Cool.
Lucien, it's Derek here. Is it just me, or does AWS Developer Tools suck? Those code pipeline, code commit, those things are, it's painful if you come from Bitbucket Cloud or GitLab. I mean, that's just, or did I use it wrong?
So AWS does have a code suite of services, specifically to the link I showed above, where we're dictated in which services we can use. So this is a financial institution, and we did take a look at using Azure DevOps, which ran as a POC. That has a lot of, well, that's pretty much GitHub or Azure, or whichever way you want to speak to it. But I found the AWS services to be significantly easier. You just need to create your role, make sure your role is able to speak to the services that you need. And then from a code commit perspective, we had to build a lot of the functionality around how we're running our branches and that kind of strategy. And it was from that approach was where we applied more of a GitOps approach. And that way we had a master branch, release branch, and our developer branch per microservice. And the developers were able to write their code as they needed. I do hear you around using something that you're more familiar with, but we did have constraints. And to be honest, it works flawlessly. It integrates extremely securely. And from the VPC, we have an endpoint to the CICD pipeline itself, and we're able to integrate and deploy through that. But yeah, it was more from a security perspective, having everything running in one cloud environment, which was in Ireland. And when you take a look at it from that kind of perspective, it's 3 availability zones in Ireland, and we're trying to use everything we can inside those 3 AZs and only cater for public traffic to break out of the on-premise DC. The only thing that's exposed are the buckets, but everything else is private communication. We're using private zones, private endpoints, and you can't beat this from a security perspective. From the pen test that we have gone through, it was quite substantial that we had nothing critical or red, and the stuff that was found was more on the application layer. So it wasn't so that's where you really need to consider your trade-offs. If you don't have the constraints that I do, Jenkins works quite well as well. But specifically, the pains that I do feel with pipeline is code commit is a bit basic. and for you to get a more fleshed out SaaS approach is not really possible, but it does the job very well. And that's all I can say there. I don't know if that kind of helped you there, Dirk.
Yeah, no, that helped a lot. Yeah, like you said, it's easy, but you still have to build quite a bit to make it nice to work with. But if it's there, it keeps on working.
Yeah, it was definitely a trade-off, but I don't know specifically. I do find that from an architecture perspective, when you're taking a look at the CICD process and you have a team of developers, I would say there's a lot of opinions that can kind of come from what to use, but specifically it does need to be agreed upon, and everyone needs to commit. Specifically, we did take a look at using a different service, but in terms of speed and agility, the code speed definitely won there. So do try run POCs, see how quickly you can build, but as a team, make a decision and solely commit to it. So yes, this was built over 3 months, which I thought was quite fantastic. And when everything was written in Terraform modules, we were able to take this across our environment. So we had a playpen sandbox environment, and this is where our devs just broke stuff like significantly. But we were able to see all the ClickOps and then be able to rewrite the code to be able to pull in all the clicks, and then we would deploy that into non-prod. And then from non-prod, we had ingested all of the security findings, and we had failed really fast with this approach. And we were able to move into non-prod and then production really quickly once we had the sign-offs, because effectively you have an artifact as code which can spin up all your infrastructure. And if you've already done the hard work up front, being able to play and change things really does come into play. And I will be honest, the cloud engineering team did have to upskill. They learned on the job, learning how to write infrastructure as code. And part of that was specific to the phase 1 and phase 2 and like the phase 3 that I kind of spoke about. And once you kind of have that baseline where you are using a DevOps scripting approach, you're able to move really quickly. So I would say infrastructure as code is more significant than the actual CI/CD process, specifically when you need reusable artifacts, and we able to see drift and those sorts of things. So it's those additional extra components that we kind of took into consideration. And the last thing was being able to understand the serverless lens that AWS provides through the WAL architecture framework. And we had the WAL architect approach. We actually have 3 availability zones. I just didn't scale it out. But in terms of the regional resiliency, we kind of stuck with just using Ireland because those are our constraints. But effectively, we had started the design with a few things in place. So we had a show nothing approach, which is the function runtime environment and the underlying infrastructure is very, very short-lived, and therefore the local resources have a very short time period, and it has a kind of life cycle. So we were able to cater for the orchestration and using events to kind of trigger the transactions. And this was how you're able to store and keep messages. And then again, you don't need Kubernetes. You don't need to use EKS. Services can run in a Lambda function, but it can also run quite indefinitely using step functions. So we are using Lambda, we are using step functions, but it's just reorchestrating everything. Great. Do I have any more questions?
What is AMS? I think I missed that in the beginning. What role does that play, Lucien?
So AMS, I'll just bring it up. Very, very cool topic. So it is something that I have learned as well recently. I've been working in AWS since 2017, and I write the client, and then I see AMS, and I'm like, huh? But effectively, I'm just going to paste this in the chat. However, what this means is we have Amazon Web Services are employed to manage your landing zone for you. Okay. And because they're managing your landing zone for you, there's a whole bunch of requirements and security and those sorts of things. So specific to financial institutions, I don't know of many clients that are using it. It's not something that's that public, but effectively, I don't know why this is taking so long. I have a 200 fiber line, anyways. So you're able to build in your AWS account, but there are specific constraints, and this is where AWS is helping you manage your landing zone for you. So we don't speak to a support. We speak directly to a specific team that's dedicated to this landing zone, and all of them work for AWS. So it's not premium support, it's not professional services, it's AMS specifically. I'll just share this chat.
Interesting.
I'm still confused.
Lucien,
even last time
what
when
is
you
the
told
cost
me
for
about
that
this.
service?
Sorry, you go, Russell.
The cost of the
Sorry,
environment.
I was just wanting to ask Lucien, what is the cost? Yeah.
So
I didn't get that.
No, I was just making sure I got your question correctly. So the cost, the biggest cost we're receiving is actually around the networking layer. So catering for the things you really kind of can't control. So data transfer, those sorts of things. But we came like most of the stuff we're using is serverless and free tier at the moment. So the costs are extremely low or almost non-existent. So the services that we're actually paying for is API Gateway, Cloudfront, and the S3 bucket, and the subdomain. The Lambda functions are all free tier. We haven't received a single cost yet. From the event bridge and the step functions, I think it came to like $30. And from the database side, I think that's where we saw our biggest cost, but that was just from things being incorrectly provisioned the first time. So in total, around $300. However, we're using enterprise support. So for each account, there's $15,000 just for a support fee. But the application workload itself is like monumental, like minimal when it's compared. So from a cost perspective, everyone's smiling. It's like almost nothing, and I'm not joking. It's crazy.
Okay. And for the AMS service, how much did those guys hit you up for that?
I don't know. There's specific agreements which would lie between the client and AWS themselves. But I'm a consultant, so I'm not involved in that kind of transaction or those kind of conversations. I'm only in charge of making sure that things are well architected well architected and they work. So I do 30% of my time is spent architecting and 70% of it's the engineering component. So AMS have specific services that they will manage for you. And this would come down to, I can bring it up, but effectively they will take a look at your databases or your VPC. And because you're using these services, there'll be an SLA between 15 to 25% extra for these services. For services that they allow you to use by yourself, which they don't manage, you pay no markup there. So this is very specific to the financial institutions using AMS.
Okay, great. Thanks for that.
I forgot
Lucien,
one question.
Okay, Rian first. You can go first.
Like back to that networking, I see both customer gateway and your direct connect there. But I'm assuming that when you said this doesn't cost much, like it excludes those networking components. You're just talking about the application.
Correct. So these costs are unavoidable, and we would pay per how much data is transferred, and you'll pay for how long it's attached to the VPC. But the direct connect is absorbed by a shared service team. Okay. And the data that's traveling, it's a few kilobytes, and it's traveling from the on-premise data center in South Africa. From the DC, it has a cross connect that's hitting Terraco, and Terraco does the gives you the direct connection into AWS, and that runs straight into Ireland. But what travels across this connection is simple messages, and these are less than, let's say, 50 kilobytes. So we have very low latency. We're not transferring a lot of data across it, and because there's not a lot of data transferring, the costs are quite low there.